Hello everyone, welcome to the course Formal Languages and Automata Theory. This is lecture number 18. In the previous lecture, we have discussed about minimization of finite automata. Here, in today's class, we are going to discuss about finite automata with output. Let me share the screen to discuss about today's concept. In today's class, we are going to discuss about introduction to Moore machine and Melay machine, transition diagram and an example with input string, and the transition table. And we already discussed at the starting of the subject, finite automata has been classified into two types, that is finite automata without output and finite automata with output. Already whatever the concepts we have discussed up to now, that is about finite automata without output, that is DFA, NFA, NFA with epsilon, and all these things that comes under finite automata without output. And now we are going to discuss about finite automata with output. Finite automata may have outputs corresponding to each transition. Finite auto may have outputs corresponding to each transition is nothing but finite automata with output. And there are two types of finite state automatas that generate output. One is Moore machine and another one is Melay machine. Now we are going to discuss about the difference between Moore machine and Melay machine. Then you can easily understand what is Moore machine and what is Melay machine. Now when you are going to observe the Moore and Melay machines here, Moore machine is a 6-tuple and Melay machine is also 6-tuple. And in previous cases, DFA, NFA and NFA with epsilon, we have only 5 tuples. And there in DFA, NFA and all those things, you will be finding the final state. But here you don't find the final state in Moore and Melay machine. Okay, and observe the tuples. Here you have Q, capital Q, sigma, capital delta, small delta, lambda and Q naught. In both the cases, you will be finding the same symbols. And Q represents set of states in both the cases, and sigma represents set of input symbols in both the cases, and capital delta represents output alphabet, and you will be finding transition function, that is Q into sigma to Q, that is a transition function that is representing a Moore and Melay machine, and you will be finding the difference only with lambda. Lambda is nothing but it is also a transition mapping from Q to capital delta, that is based on the output. And here Q into sigma to capital delta. Here what it is representing? Here the output is associated with each state. Based on the state you are going to represent the output. And here the output is associated with the transition. That's why the lambda you are going to find the difference with Moore and Melay machine. And Q naught is the initial state in both the cases, and here you don't find the final state. And when you're going to find the length of the output, suppose if you have given a string of length input, then the output you are going to get in Moore machine will be +1. Suppose I am going to have my length of the string is 2 means, then I am going to get my output as 3. And here the length of output equal to length of input. That means both are equal. This shows you the difference between Moore and Melay machine. Not only this, when you are going to see an example to represent the input string, how it will be differentiated with the 1 plus 1. Just you observe, this is the transition diagram when you are going to represent the Moore machine. If you observe the states, here the states are represented with outputs. It is representing the output. Q0 output 0, Q1 output 1 and Q2 output 2. And here in the Melay machine, you are going to represent the output on the transition. After the transition, what is the output you are going to get? That means Q0 on 0, what is the output? Q1 on 1, what is the output by moving to Q1? Like this way, the difference you are going to find with the transition diagrams also. And when you are going to see the input string, suppose if I am going to take 101 as the input string in Moore machine, then I'm going to represent lambda in this way. That is Q tends to lambda. That means it depends on the states. Now Q naught on 1 it is moving to Q1, Q1 on 0 it is moving to Q2, and Q2 on 1 it is moving to Q2. Now here you are going to represent the output based on the states. Why means already we have represent the output for the states. That's why we are going to represent output for the states. That's why you are going to get 0, 1, 2 and 2 based on the states which we have taken. This is for Moore machine. And what about the Melay machine? Based on the transitions only we are going to give the output. That's why Q0 on 1 it is going to Q1, Q1 on 0 it is going to Q2, and Q2 on 1 it is moving to Q2. Now based on the transition, here this is representing the transition, right? On 1, Q0 on 1, what is the output you are going to have? Here you have 1. That one we are going to represent. On the transition, what is happening? Q1 on 0, what is the output you are going to have? 2. That should be represented. On transition, Q2 on 1, you are going to have the output as 2. That's why you are going to get 1, 2, 2. This will be of n plus 1 length, and this will be of output will be equal to length of input. And coming to the transition table. In the similar way, you'll be finding the difference between the transition table for Moore and Melay machine. And here we are going to have the state. You can represent it as present state also. Then next state with the input symbol 0 and 1, and you are going to have the output. Output will be represented with lambda. And on Q0 on 0, it is going to Q0, Q1. On 1, it is going to Q1, and lambda output is 0. And you know how to represent the transitions, but here you need to represent the output also for the Q0, Q1 and Q2 based on this diagram we have represented. Okay, Q0 output is 0, Q1 output is 1 and Q2 output is 2. Now here for each state we are going to have the output. That's why based on the input symbol, on the transitions the output is going to be different, right? For Q0 on 0, it is moving to Q0 state, and then it will be having the output 0. Q0 on 1, it is going to state Q1 and the output is 1. That's why we are going to represent them separately. Like that way, we are going to represent for Q1 and Q2 also. And by the end of this lecture, the student can able to define what is Moore and Melay machine, and they can able to differentiate Moore and Melay machines, and they can able to draw the transition table and transition diagram, and they can able to, if I am going to give an output, if I am going to give an input string for them, then they can able to find the output by using Moore and Melay machines. Thank you.